All right, guys, this is the second part of our Chapter 2 test review. Your test is going to be on Tuesday, and it's going to cover everything that we're talking about today. So I need to make sure that you guys follow along. If you have questions, you need to email me over the weekend. I'll do a Zoom study session Monday afternoon, so you guys can jump on and ask me questions if you have anything. But let's go over, the first thing I'm going to talk about is numbers 34, or 35 and 36. And we talked about these way back at the beginning of Chapter 2. You may have to use the quadratic formula on this test for various parts. You need to know how to use the quadratic formula. You're going to have to in these problems that I'm working on right now and something a little later in the review. So I want to make sure you guys are understanding how to use that, when to use it in these situations. So if we look at number 35, okay? First thing I want you to remember is domain. Every single parabola that we'll ever look at, the domain is going to be negative infinity to positive infinity. So that's real important that you guys understand that. This parabola itself is positive because your A term is positive, so it's going to be going up. That means we're going to have a minimum value right here. Our minimum is going to be at y equals whatever part of the vertex is. Your axis of symmetry is the x part of your vertex, which is important to understand. We can look at this and find our y-intercepts, because to find y-intercepts, you just plug in 0 for x. So if I plug in a 0 here and a 0 here, I see that my y-intercept is going to be at 0, negative 2. So we can identify that. In order to find our x-intercepts, this is where we have to factor. So we'll do that in a minute. Not right now. We'll do it in a second. So I want to make sure we are all good to go on this stuff. I don't know why that's black right there. I need to erase. It's not erasing. Okay. All right, so let's go through and find our vertex first, okay? The way that we find our vertex is we have that tiny little formula that is so very helpful. And we will probably have fractions. Fractions are okay. I want you guys to understand that. So I have x equals negative b over 2a. So I look at my function, all right? This is my b right here, negative 5, and this is my a, which is positive 3. So I have negative 5 over 2 times a, which is 3. So I work this out and I get positive 5 over 6. So the x part of my vertex is 5, 6. Just leave it like that. That means my axis of symmetry is at 5, 6. That's the vertical line that cuts my parabola in half. Now in order to find the x part of my vertex, my y part, I take my x value and just plug it in. So I'm going to say, okay, fine, well, y equals, and I have 3 times 5, 6 squared minus 5 times 5, 6 minus 2. Now, guys, this is just basic algebra. It's not the most fun thing in the world. I understand that, but we can all handle working with fractions. So the first thing we need to do is remember that this 2 is distributed to both the numerator and the denominator. So I have 3 times 5 squared is 25 over 36 minus 5 times 5 is 25 over 6 minus 2. So now let's just go through and simplify. 3 goes into 36, 12 times. So I have 25 over 12 minus 25 over 6 minus 2. So now I'm going to get a common denominator. So my common denominator, obviously, between 12, 6, and 1 is going to be 12. So I have 25 over 12. In order to change 6 into twelfths, I have to multiply by 2. So if I multiply the bottom by 2, then I multiply the top by 2. So that becomes negative 50 over 12. Now, if I want to change negative 2 to twelfths, I'd multiply the bottom by 12, so I multiply the top by 12, and I get minus 24 over 12. So now, again with simplifying, 25 minus 50 is negative 25, minus 24 gives me negative 49 over 12. That is the y part of my vertex. It's at negative 49 over 12, okay? That's also the minimum value at y equals negative 49 over 12. So when I talk about range, right, my range is from bottom to top. So we are at negative infinity and then this point at the bottom is negative 49 over 12, and then we have positive infinity. So my graph exists, guys, up here in this area. So my range would be from negative 49 over 12 to positive infinity. And it includes negative 49 over 12, so I use a bracket. The last thing we need to do is our x-intercepts. So in order to find x-intercepts, remember, we set our quadratic equal to 0. So 3x squared minus 5x minus 2 equals 0. So we're going to factor a times c, negative 6. What are the factors of negative 6 that multiply to give me negative 6, but add to give me negative 5? So that would be x minus 6 and x plus 1. Since my a term is not 1, I'm going to put it underneath each of my factors. So this becomes x minus 2, and this becomes 3x plus 1 equals 0. And when I solve that, I get x equals 2 and x equals negative 1/3. So my intercepts would be at 2, 0, and at negative 1/3, 0. Again, we're not asking you to graph. There's no graphing involved for this problem. It's just a matter of finding everything. Okay, so now we're going to go over to the second one. Exact same thing. This one's a little more difficult because it has a negative and it doesn't factor pretty, but we can still do it. So the first thing we're going to answer is our domain. Our domain for every parabola we ever see is negative infinity to positive infinity. All right, this is a negative parabola. My a term is negative, so I know it's going to go down. So that means that point right here is the maximum. That's the highest that this point will go. It's going to be at y equals whatever part of the vertex is. I know my axis of symmetry is x equals whatever part of the vertex. When I plug in 0 here and here, I find my y-intercept. So my y-intercept is going to be at 0, 1. Now we're going to go through and do a little work. Okay, so now we will go through and we will find our x and y. I have no idea what happened to my eraser and why it colored over our problem, so I'm just going to rewrite up here. It was negative 2x squared plus 3x plus 1. That's our g of x. So in order to find my vertex, guys, we have to use our negative b over 2a. So I have x equals negative b over 2a. So negative b, my b is 3, so it's negative 3 over 2 times negative 2, since a is negative 2. So I have negative 3 over negative 4 gives me positive 3/4. So my vertex, the x part of my vertex, is 3/4. That means my axis of symmetry is at x equals 3/4. Now I'm going to take 3/4 and plug it into my function to find out what my y value is. So I have negative 2 times 3/4 squared plus 3 times 3/4 plus 1. Again, this 2 goes to the numerator and the denominator, so I have negative 2 times 9 over 16 plus 3 times 3 is 9 over 4 plus 1. So this becomes a negative 1, and this is an 8. So I have negative 9/8 plus 9/4 plus 1 equals my y value. So let's just get a common denominator. Between 8, 4, and 1, it's going to be 8. So negative 9 over 8 plus, if I want to change 4 to 8, so I have to multiply by 2. So what you do to the bottom, you do to the top. So I have 18 over 8 plus, if I want to change 1 to 8, I multiply the bottom and top by 8. So plus 8 over 8. When we simplify this, negative 9 and 18 is 9, and 9 plus 8 is 17/8. So my y part of my vertex is 17 over 8. That means my maximum value is y equals 17 over 8. So now let's look at our range. So my range, this is negative infinity down here. This point right here is 17 over 8, and there's positive infinity up here. So my range, my function exists down here in this point. So if I'm reading from bottom to top, my range would be negative infinity, and the highest it goes is 17 over 8, and that has a bracket on it. Now the last thing we need to do is find our x-intercepts. So if I take my original equation, which is negative 2x squared plus 3x plus 1, and I said equal to 0. The first thing I would tell you guys to do is take out that negative. So you're left with 2x squared minus 3x minus 1 equals 0. If you guys try and factor this, negative 2. Factors of negative 2 that multiply to give me a negative 2, but add to give me a negative 3 does not work. You will not find any. So we're going to have to use our quadratic formula. So go back to your original, negative 2x squared plus 3x plus 1 equals 0. My a term is negative 2, my b term is 3, and my c term is 1. So I have negative 3 plus or minus the square root of 3 squared minus 4 times a is negative 2 times 1 all over 2 times a, so 2 times negative 2. Negative 3 plus or minus, I have 9 plus 8 over negative 4. Gives me negative 3 plus or minus the square root of 17 over negative 4. So your x-intercepts, guys, would be at negative 3 plus root 17 over negative 4, comma 0, and negative 3 minus root 17 over negative 4, comma 0. Those are your x-intercepts. So just make sure you guys are aware. You will probably have to use the quadratic formula at some point, and that's okay. All right, second thing I want to look at is how to find the zeros. I'm sorry, not the zeros, but you want the linear factors of a problem. So let's look at something like number 2. All right, when we do a problem like number 2, when you're finding the linear products, all you're doing is finding the zeros and just going one step backwards. So the first thing I want you guys to do here is we ultimately want to find out what x equals. So let's factor. I look for a GCF, there is not one. I look to see if I can group, grouping's not going to work. So that means we have to use our P over Q. So I'm going to take the factors of 19. So it's plus or minus 1 and 19, all right? I know you guys like to start with, you sometimes get a little crazy, start with whatever. I'm going to start with 1 and just see if it works. If it doesn't, we'll move on to negative 1, no big deal. Write out the coefficients of all of your variables. Make sure there's no gaps. It goes 3, 2, 1, nothing. Okay, good. So bring down the 1. 1 times 1 is 1. Negative 7 and 1 is negative 6. Negative 6 times 1 is negative 6. 11 minus 6 is 5. Is this one going to work? No. So then try negative 1. Again, write out your coefficients. 1, negative 7, 11, and 19. Bring down your 1. So 1 times negative 1 is negative 1. Negative 7 and negative 1 is negative 8. Negative 8 and negative 1 is 8. 11 and 8 is 19. And 19 times negative 1 is negative 19, so I get 0. So that just proves that x equals negative 1 is a factor. So over here, I'm just going to write real quick, x equals negative 1. Now my resulting polynomial is x squared minus 8x plus 19 equals 0. We really hope at this point that this would factor, but it doesn't, so that means we're going to have to use our quadratic formula. So I have negative 8, because negative 8 is my b term, plus or minus the square root of negative 8 squared minus 4 times a is 1, c is 19, all over 2 times 1. At this point, please check to make sure that you have all of your numbers in the right spot, your signs are correct, all of that good stuff, because if not, then the rest of your problem is going to get messed up. So now as we evaluate and we simplify, negative gives me 8 plus, I have 64 minus 76 all over 2. At this point, you guys should realize, okay, underneath my radical, I'm going to have a negative, which is okay. Just means we have an imaginary solution. So I have 8 plus or minus square root of negative 12 over 2. We have to break down negative 12. So it's 4 times 3 times negative 1. The square root of 4 is 2. Square root of negative 1 is I. So this actually becomes 8 plus or minus 2i root 3 over 2. Now it's important here, guys. I think it's very important in this step or game or whatever part in the equation that you separate this, because you can see the simplification better when you do. 8 divided by 2 is 4, plus or minus 2 divided by 2 is 1, so you have I root 3. So what we just found out here and I'll write it up here, is you have x equals 4 plus I root 3, and you have x equals 4 minus I root 3. Now, they are not asking you for the zeros. They want the linear products. That means they want you to take the 0 and go one step backwards and put it into a parenthesis. So we're going to do that right now. If I take x equals -1 and I move -1 to the other side, it becomes x plus 1. If I take 4, positive 4 plus I root 3, that becomes x minus 4 plus I root 3. If I take positive 4 and I move it to the other side, this becomes x minus 4 minus I root 3. And then our last step is going to be just distributing that negative sign here. So I have x plus 1. When I distribute this negative, it becomes x minus 4 minus I root 3. And when I distribute this negative, it becomes x minus 4 plus I root 3. And there is your product of linear factors. All right, let's do another one. I'm going to try this one because it looks kind of long, right? This is x to the 4th. That means I'm going to have 4 answers. So the first thing I'm going to do is look to see if there's a GCF. There is not one. So then I'm going to look to see, okay, well then can I group or anything? Well, you can't with 5 terms. So we just have to go to plus or minus. Got to do our P over Q. 1, 2, 4, and 8. Again, you guys are going to start with whatever you want. I'm going to start with 1 because I always do that. So I have 1, -6, -4, and 8. Are there any gaps? 4, 3, 2, 1, none. Nope, we're good. So bring down your 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. -6 and 2 is -4. -4 and 1 is -4. -4 is -8. Oh, good. -8 times 1 is -8. So I get 0. So one of my factors, one of my zeros, is x equals 1. So I'm going to go up here and just write x equals 1 so I don't forget. Now, when I look at my resulting polynomial, I look at what's left. I'm left with x cubed plus 2x squared minus 4x minus 8 equals 0. See if you can group this. And we absolutely can. So this leaves me, I take out x squared, and it leaves me with x plus 2. I take out a -4, and that leaves me with x plus 2 equals 0. So I'm going to come up here. My x plus 2 comes out in front, and then whatever's left over gets its own parenthesis. So I have x squared minus 4. You guys should notice there, ooh, that's the difference of perfect squares. So x plus 2, and then this becomes x plus 2x minus 2, and we're good. Now, if I asked you to solve this and tell me what the zeros were, you guys would tell me there's -2, -2, and +2. But they want their answer as a product of linear factors, so it's already done for you here. We can rewrite this as x plus 2, x plus 2, x minus 2, and then I have one more linear factor. If I move that 1 over, this becomes x minus 1. There's our product of linear factors. Some people ask, do I have to write x plus 2 twice? Yes, absolutely. Because I'm not asking you to solve and you telling me that there's 2 zeros at -2. You actually have to have that linear product so I can see when I multiply together, that's what I get. Quickly, let's go up to, if I look at number 1, all right, take out a GCF first. If I take out the GCF of x, I'm left with 4x squared plus 4x plus 1. Well, if I factor this, 8 times c is 4. What can I say? What times what gives me +4 when I multiply and a +4 when I add? It'd be x plus 2 and x plus 2. Now, since our a term is not 1, I have to put that 4 underneath. So this becomes 1/2. And this one becomes 1/2 because it simplifies a little bit. So if I was going to rewrite this, it'd be x times, this 2 would come out in front, 2x plus 1. That 2 would come out in front. 2x plus 1. There's our product of linear factors. My zeros, if I solved it, would be x equals 0, x equals -1/2, and x equals -1/2. But that's not what they're asking for. They want the product of linear factors. So if we look at something like this, GCF first, take out the x, and I'm left with x to the 4th plus 5x squared minus 14. Well, this factors. What times what gives me x to the fourth? I get x squared and x squared. What times what gives me a negative 14 when I multiply, but a positive 5 when I add? Be plus 7 and minus 2. Okay, this is not the difference of perfect squares or anything, but I can solve this. I have x equals 0. X squared plus 7 equals 0. X squared minus 2 equals 0. So x equals 0 is fine. Here, I'm going to move x squared negative 7, take the square root. I get x equals plus or minus I root 7. If I add 2 to both sides, I get x squared equals 2. Take the square root. I get x equals plus or minus root 2. So to write as a product of linear factors, right, I have x equals 0. X equals plus or minus I root 7, and x equals plus or minus root 2. So if I go backwards, x plus 0 or whatever just gives me x, that's fine. When I take this and move backwards, I'm going to have x minus I root 7, x plus I root 7. And when I take this and go backwards, I'm going to have x minus root 2 and x plus root 2. So there's a variety of answers that you're going to get, guys, but I want you to understand, look, I have 1, 2, 3, 4, 5. If I go back to my original, 1, 2, 3, 4, 5. Okay? All right, on a problem like this, guys, when you are given a 0 and you have to find all of the zeros of the function. If I look at number 15, my function is raised to the third power. That means I'm going to have 3 zeros. So they gave me right here, this first one, x is 3 plus 2i. That means they also gave me the conjugate, which is x equals 3 minus 2i. So I have one more x, one more 0 that I need to find. So the first step in solving this is you're going to take x equals 3 plus 2i and x equals 3 minus 2i, and you're going to multiply these complex zeros together. So if I take 3 plus 2i and move it over here, this becomes x minus 3 plus 2i. Then I'm going to take this positive 3 minus 2i and move it over. This becomes x minus 3 minus 2i. Now before we do anything, we're going to distribute this negative sign. So I have x minus 3 minus 2i, and then I have x minus 3 plus 2i. If you guys notice, I have x minus 3 and x minus 3, so that gives me x minus 3 quantity squared. And then I have a 2i and a 2i, so that gives me 2i quantity squared. And we have different signs, so we're going to put the difference in the middle. When I distribute this exponent, it goes to the 2 and to the I, so this is 4i squared. As soon as I see I squared, I cross that off and I put a plus sign. So this is plus 4. This is just x minus 3 times x minus 3. So that's going to give me x squared minus 3x plus 9, and then I have my plus 4. Combine like terms and our constants, we have x squared minus 6x plus 13. Now what I'm going to do with this polynomial is I'm going to take this polynomial and divide x cubed minus 11x squared plus 43x minus 65 divided by x squared minus 6x plus 13. And when we do this, guys, you should come out with a nice pretty answer, no remainders, and that'll be your 0. So long division, x squared into x cubed. X squared times what gives me x cubed? We would say x. I'm going to put that right above my 43x. Get your subtraction ready before you multiply. X times x squared is x cubed. X times negative 6 is negative 6x squared. And x times 13 is 13x. So we have to distribute this negative sign all the way throughout. So 43x minus 13x gives me 30x. That's a positive. Negative 11x squared and 6x squared gives me negative 5x squared. And my x cubes cancel out. So I'll bring down my negative 65 and we'll do it all over again. We'll say first term, which is x squared, into negative 5x squared. So we'll say x times what gives me negative 5x squared? Be negative 5. So get your subtraction ready before you multiply. Negative 5 times x is negative 5x squared. Negative 5 times negative 6 is plus 30x. And negative 5 times 13 is negative 65. Distribute that negative sign throughout. And we have negative 65 and positive 65 is 0. Positive 30x, negative 30x is 0. Negative 5x squared, positive 5x squared is 0. So we're left with x minus 5. We set that equal to 0. And we find out that x equals positive 5. So your three answers should be x equals 3 plus 2i, x equals 3 minus 2i, and x equals 5. We'll do the same thing on this problem. I'll do this one for you guys, and then we'll be good to go. All right, we're given this 0 right here. So I have a 0 that is x equals negative 2 minus 5i. That means I also have a 0 of x equals negative 2 plus 5i. Negative 2 plus 5i. We have to account for our conjugate. Okay, so we're going to work backwards here. We're going to take this entire 0 and bring it over here. So I'm going to have x minus, I have negative, if you want to make this a plus from the beginning, you're more than welcome to. We can do that. So I'll have x plus 2 minus 5i. And then I'll bring this one over, and I'll have x plus 2 plus 5i. And again, guys, look here. I have x plus 2 minus 5i, x plus 2, whoops, plus 5i. So I have my x plus 2 twice. I can write that as x plus 2 quantity squared. I have a 5i and a 5i, so that gives me 5i quantity squared, and I have my minus sign in the middle. So distribute this exponent to the number and to the I. So I have minus 25i squared. I see I squared, cross it out, change the sign. So now I have x plus 2 quantity squared. So just FOIL it, x plus 2, x plus 2. That gives me x squared plus 2x plus 2x plus 4 plus 25. So I have x squared plus 4x plus 29. So I'm going to take this polynomial, and I'm going to take my original, and I'm going to divide them. So I have x cubed plus 11x squared plus 57x plus 203. And I'm going to divide that by x squared plus 4x plus 29. And again, when we do this, guys, you should get something nice and pretty. So x squared into x cubed. X squared times what gives me x cubed? I get x. So get your subtraction ready before you multiply. So we have x times x squared is x cubed. X times 4x is plus 4x squared. And x times 29 is plus 29x. So before we subtract, we're going to distribute my negative all the way through. So I have 57x minus 29x.
Can you listen for a second? I have to run and grab my jacket.
Yeah, sure. Yeah, you need to have one in here at all times.
I know.
This room is like the Arctic. Oh, thank you guys.